In this video, we're told that triangle ABC is similar to triangle DEF, and we're asked to describe a sequence of rigid motion followed by a dilation with the center 0, 0 that will map ABC to DEF. In other words, we need to move this triangle into this quadrant and increase it so that it'll essentially map on top of, triangle DEF. So let's just review what similar figures are. Similar figures are the same shape but different sizes. In other words, the corresponding angles on the shapes are going to be the same or congruent. So for this triangle, angle A corresponds with angle D, angle B corresponds with angle E, and angle C corresponds with angle F. And I know that C and F are equal or congruent, B and E are equal or congruent, and A and D are congruent. All right? And I also know, the other thing about similar figures is that the corresponding sides, well, they're related proportionally. In other words, there is a scale factor between AB and DE. And I don't know what it is yet, but I'm going to find that out. And I know that that's true because I was told that they were similar. So if they're similar, the corresponding sides of each of the shapes have the same proportion of increase or decrease, and all of the corresponding interior angles are congruent. All right, and as you know, this said that it was a center of the dilation was 0, 0, which means that from this center, if I draw a line through it, and I kind of lightly traced one, you might already be able to see it, one of these points, and I think I know which, is going to probably be around the origin. So I'm going to start by moving this over. And my clue here is that I know that one of my points is going to have to end up on this line somehow. And what I can see is that my best candidate, just visually to me, looks like C. So I'm going to start seeing what it would take to move this over. If I move C over 1, 2, 3, and up 1, I will end up here. And so if I moved B over 3 and 1, where would I end up? 1, 2, 3, and 1. If I moved A over 3 and 1, I'd end up with 1, 2, 3, and 1. All right, so that one point, C, moving at 3 and over 1, puts me on the center of dilation. So I am saying that the transformation for xy here would be x minus 3, y plus 1. That would be my translation. All right, now once I do that, my question becomes, how large are these sides? How much bigger is the side on DE, for instance, than it is to AB? How large do I have to dilate this to get it to where I want it to be? And that's a great question. So let's see what we can come up with. All right, so now I'm going to dilate, and I'm going to count the distance because I can easily do it on BC. Let's see, this from here to here is 1 unit. From here to here is another unit. So the length of BC is 2 units. Let's see what the corresponding length is on EF. It is 1, 2, 3, 4. So EF, and what did I say? BC. I wrote a 4. Sorry, that's BC. So this was 4 to 2, which simplifies to 2, which tells me that the scale factor here is 2. So K equals 2. And my answer to this question would be, what are the series of rigid motions? It would be moving the shape ABC, the triangle 3 to the left and 1 up, followed by a dilation of 2. Pardon me, I think I just need to move that up. There you go.